This video is brought to you by the volunteers of the Santa Fe Alliance for Science. Today I'm going to talk about Fibonacci and his numbers, the Fibonacci numbers. Fibonacci, his name was actually Leonardo of Pisa, but he called himself Fibonacci, the son of Bonacci. He lived about 800 years ago in the city of Pisa in Italy. Nowadays, the city of Pisa is known for its leaning tower. By coincidence, the tower was being built while Leonardo was living, but it wasn't finished when he died. So one day Fibonacci posed himself a problem. He said, what if I put one pair of baby rabbits in a field? How many rabbits would there be in the field after a year? And the rules were this: it takes 1 month to grow into an adult rabbit from a baby rabbit, and an adult pair will produce a pair of baby rabbits every month. So let's see what happens. The first month there is one pair of baby rabbits. In the second month they have grown up. There is still one pair. In the third month the grown-up pair now has a set of baby rabbits, so there are 2 pairs of rabbits. In the fourth month the original pair once again has a pair of baby rabbits, and the little ones from the previous month have grown up. In the fifth one, the original pair again has a pair of baby rabbits. The ones from the month before have another pair of baby rabbits, and the little ones from before have grown up, so now there are 5 pairs. Then the next month there is 8, and so on. So let's have a look at these numbers. The first number was 1. The next one was also 1, then came 2, then 3, then 5, and 8, and that's where we stopped. Now, let's do this. 1 plus 1 makes 2. 1 plus 2 makes 3. 2 plus 3 makes 5. Aha! 3 plus 5 makes 8. So what do you think the next number is? The next number is 5 plus 8 is 13. So the original question is, how many rabbits would there be in a year? So the 12th number, and you can check that for yourself, the 12th number is 144. So after a year, 144 rabbits would be in the field. Here is a fun thing you can do, especially if you have a sheet of paper with squares on it. Outline one of the little squares, and then next to it you can draw another square of size 1. On top of it you can draw a square of size 2. 1 plus 1 is 2. Next to it, a 3. 1 plus 2 is 3. 3 plus 2 is 5. 3 plus 5 is 8, and you can go on and make this beautiful spiral. These are the kind of shapes that you find in nature a lot. This, for example, is a nautilus shell cut in half. Fibonacci numbers are everywhere if you know where to look. Let's go to the grocery store and check out the produce section. So here we have a pineapple, and you can see that the bumps on the surface of the pineapple make these patterns. They come in rows that you can follow in different directions. This way, there are rows that go this way, there are maybe vertical rows that go this way, and let's count how many rows there are on the circumference of the pineapple. So on this side I put some tape that follow some of the bumps in this direction, and here you can follow some of the bumps in that direction. Let's count those. So first let's look at the blue stripe. It follows the bumps that go in this direction, and we'll see how many there are as we go around. So we can go 1, 2, 3, 4, 5, 6, 7, and 8, and then we're back to here. So this is 8. Now let's look at the white ones. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And we're back here. So this is an 8 and a 13. There is even a third direction that we can explore. See this one, how they line up vertically? Let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and we're back. So there is even a third one with another Fibonacci number, 21. So here is an artichoke, and you can again see that the leaves, they form patterns. They go around in spirals, and they line up this way, or you can follow them this way. Here's another spiral. Let's see how many spirals it takes to go around. So I've marked one of the directions with white tape, and let's see how many of those spirals we can find as we go around. So we go around 1, 2, 3, 4, 5, 6, 7, 8, and we're back. So this is 8. In the other direction, there are spirals going this way. So let's count these. So we go 1, 2, 3, 4, 5, and we're back. So this is 8 and 5. Another vegetable that shows Fibonacci numbers is asparagus. Next time, when you're in the store, see if you can count 5 and 8. Look around the house and outside and see what you can find. I found this little seed here on a path. It's got beautiful spirals in both directions, you can see. The other thing I discovered is that one of my cacti has spirals in it. I counted them and I counted 8 in the yellow direction. See the yellow spirals here? 8. And then 13 red ones as you go around. 13 spirals in the red direction. I also found a picture of a sunflower. Sunflowers, they really are something else. This one has, in the blue direction, the one that is indicated here, there are 55 spirals going around. And in the other direction, this way, these spirals here, indicated by red, there are 34 as you go around. 34 and 55 are two large Fibonacci numbers. That is really spectacular. So go outside, go around the house and see what you can find and count them. One last thing, pine cones. So here are some pine cones I picked up from the street in our neighborhood, and they're all different. There are many different kinds. If you pay attention, not all pine cones are the same, and the numbers that they show are also not the same. I'll do one here, and you can follow the same method. You can take a marker and mark one direction or another direction, and then count. So let's do this one. 1, 2, 3, 4, 5, 6, 7, 8, and we're back. And the other direction. 1, 2, 3, 4, 5, and we're back. So this is 8 and 5. They're not all the same. So go out, pick up some pine cones, and look for yourself. That's it. See you next time.